And hello, it's the third one, live streaming. So, in the last episode we end up here at parsing get next opcodes and at this huge if that handles move instruction. And there were problems with SCD from cars and yeah, and I was wondering whether such move, such huge if can be handled in some prettier way. And so first off we'll try to resolve the issue with from cars, and for some reason um, my Clank 7 not able to include such thing. Look. And I decided to not care about this. So instead of from cars, which is obviously better than S2 unsigned long tool, we'll use tool. We are going to use tool to not bother with the compilation errors and just go with the implementation. So yeah. So instead from cars, we're going to just my pointer here. So as to ascend long, let's say, and we are going to create another string from the string view. So to know ptr and it should work. I should include string. Memory pointer. Let's try. Okay, const. Let's make it const. Okay, let's not make it const. Parse can't be const because we are going to change iterators. Yes. Const everywhere. Shit, I stink. Okay, we don't have a stink. String, we need string. Mem pointer. Okay, so that's not necessary. Warning. Yeah, warning is okay. Optional. Okay, so here we try to pass an optional break opcode. Okay, we should reference it. And once more. And here register opcode should not be an optional. Cool. So now it kinda works. Let's see what we have in our Git. Last is implemented parsing move. Okay, so we just fixed another problems with compilation. So let's just add these two and create a new commit. In is okay, and like I said, I wondered for a while what to do with the move, and I decided to not bother so much. So we are going to, in the get next opcode, we are going to have just one if for now, and let's extract the if body to another function like get next move or get move simply. So yeah, so get next opcodes, and now like get move, and here let's just cut and copy the body here. Later we are probably going to create a map to not have ifs but one map, but with map we would need to have map of functions, so we would probably pass a lambdas there. But yeah, let's see, let's create a, let's implement another instruction like add, and let's see how it goes. So get move. Cool. So yeah, extracted move to its own function. Yep. Okay. If current is, let's say, add. I know that's ugly, but let's see how another functions are going to be implemented. If there is going to be similarity, we just then we just like extract very similar code to one more generic part of code or part of functions. So yeah, add. Return get add. We of course don't have get add yet, so let's create it. Okay. So add as actually the same. Like it has the same set of instructions in the way that like how it looks, because the first token is instruction, then we can have register, and then we can have register or memory cell, or in the third one you have instruction, memory cell, and register. So I think at this point we should just extract. Okay, for now let's just copy it. So we're eating here instruction. If current is register, cool. Get reg. First register. If we can go, okay. Eating register, eating comma. If another register or not. So we basically only move. Yeah, only. Okay, in move we forgot to handle the third one, where current is not register, but it's like memory cell. So let's handle that. And as you can see, memory cell memory cell is like open square bracket, get pointer, and open close square brackets, and it is exactly done here. So let's extract it to another function. So for now, let's just remove and get add, and from here now opcodes. Now let's create a function that is going to return std aside int memory access, let's say. And memory access is going to eat open square bracket, close square bracket, and memory pointer inside. Return mempr. Okay, so yeah, let's just memory access. Later we should probably handle errors like missing square bracket and closing square bracket. Of course, failed parsing of int from string. But for now, let's omit that. Okay, if current is register, get register else. If it's not register, we need to. Okay, we ate a move. We need to get memory cell, memory access. So memory pointer, memory access. Now let's hit comma. Okay, let's hit comma, and now we need a register. So yeah, eating a register, parsing registers is also quite common option, quite common like action here. So when it of course looks the same always, so let's extract that too, and it is going to return optional register opcode str to reg. Okay, memory access, let's move it here, and let's create a register. Parse memory, like yeah, I don't like parse because it's quite redundant because we are inside the parser, but actually it explicitly says what function the method is supposed to do, so let's keep it like that. Okay, let's remove it, rename it. Okay, there is parse register, and it's going to look like this. Reg opcode. Cool. So parse register is going to handle the errors in case of any errors. So let's use it now. Reg opcode. Okay, I shouldn't have remove that. Okay, let's just copy. Yep, reg opcode. Reg opcode is parse register. Cool. If not register, let's raise another error again because error is raised here. Yeah. So basically, let's try to parse register. If we get a null opt, let's remove empty opcodes. Cool. Same here with another register with the second one. Yep. Cool. It's a lot cleaner now. The move, it's not perfect though, but it's of course better. Obviously better. Okay, so now parsing the third option is trivial. So we get memory pointer, and let's get reg opcode. Reg opcode. And now, if reg opcode is okay, let's return opcodes. So yeah, we need to create, not create. Let's return move mem reg. Yep, because first one is memory, then register. Reg opcode, yes, but in the reverse order. So first is memory pointer, and the next one is register. Cool. Yeah. So move is handled. And now, okay, so move is handled, and if we would like to make it a more general, because move, add, sub, multiply, divide, and compare actually have very same like instructions, very similar instructions. So, and the only thing that changes here is this first opcodes. So to make it like generic, more generic, let's create another function that handles whole that and returns opcodes with, of course, not moves, but it gets opcodes that instructions that it gets from at the input. So yes. It's going to return opcodes, of course, and let's name it get. How to name it? Get, yeah, for now to get memreg instruction, and it's going to we need to register opcode. Okay. Let's forward declare instruction opcode so we can pass it as a parameter here. So instruction opcode is reg. Next one, instruction opcode is reg memory, and instruction opcode is memory rec. Now, do we need anything more? Let's take a look at the move. Nope. That's the only thing. Now we need to cut it from here and just paste it. It's not going to be move, but it's going to be instruction. Yes, and instead of explicit move, hard-coded move, let's return such opcodes. So now, to parse, for example add, we only need to call this function, with 3 opcodes that we expect, 3 instructions that we expect, and let's make it alive. Okay, so instruction opcode move reg, cool. Instruction opcode move reg memory and move memory reg, and done. Get move. Get move is now pointless here because it's calling another function. So let's move it to this function. Or not, it's going to be simpler. I mean, it's simpler to just call get move and move handles as implementation details that it needs to have. So let's keep it like that, at least for now. Now get add. And get add is move it here. So get add is add. Cool. Cool. Next one. Okay, let's format it like that. Add sub. Okay, let's create more sub. There is multiply. Moldiff. And compare. Okay, get sub. Plan didn't generate get sub yet, so let's implement those. Small regreg. Divide. Yes, compare. Tempe. TMP. Tempe is in Polish. Yes. TMP memory register. And the last one, sub. Sub. And sub. Cool. Okay, now let's implement one operand instructions. So it's going to be increment, decrement, and jumps. Okay. If it's increment, get increment, decrement, and jump. Jump equal, jump less, and jump greater. No, jump. Jump equal plus jump greater. Okay, and those are all the functions. So all the instructions. So let's make it alive. That is going to be better. So yeah, get increment, decrement, jump. Yes, and the last one. I should probably, or not. Anyway, I was wondering whether call it parse, move, parse add, parse sub, and etc. But let's now just implement them. Okay, how? Nope. How they look like? Inc is increment register, or inc memory cell, and dec is actually the same. Okay, let's implement inc. So eating inc element. Yes, and now if current register, what did we do in case of register? Like that. Oh yes, comma, not, we are not eating comma. So let's just if register is okay. Let's return increment instruction opcode inc register and reg opcode. Cool. If it's not register, let's parse memory cell. Parse memory access and access, not access. And it's increment reg mem pointer. Cool, the decrement is going to look exactly the same, so let's extract this to another function. Get okay, instruction opcode register and memory. It's going to look like this. And so let's eat instruction. Okay, shit, I have problems with CLion recently because while generating functions, memory. Okay, so now in increment and let's pass those two operands, not operands, those two opcodes. And decrement, that's register. Good. Now let's create the one for jumps. And jumps are simpler because they get only instruction pointer, not memory cell, not register, just instruction pointer. So okay, let's not call it in IP, but instruction. And here, how it's done in memory access, it is done like this. Shit, okay, I think we should here eat. Okay, we are eating the pointer. Okay. So okay, let's create another parsing method to parse a number. Because parsing memory access and parsing instruction pointer is going to use it. Okay, person number, and it looks like this. Eating. Okay, comment is useless here. Let's just return that. We don't care, of course, for now about exceptions and malformed numbers. Parse number, and let's return instruction and with instruction pointer. So get jump. It works. Parse number. Let's use parse number in here. Sorry. Parsing number. Okay. Parsing number, cool, and the jumps. So get jump. JMP. I mean, JMP is in Polish again. JMP. It's jump equal. Jump less. And the last one, jump greater. Let's try to compile that, and it compiles. Now let's see what do we have in the tests. Okay, we don't have tests for parser. And let's not implement that now. Get jump works. Let's create a commit. What did we do? So we basically implemented the rest of the instructions, so yep. Now okay, so we have now parse method, which is getting next opcodes. It's not doing anything with the opcodes, which is bad. Here okay, first one, get the next opcodes. Let's assert here. Not assert, let's raise an error. About unknown instruction. Okay. Okay, after erasing error, let's return an empty opcode vector. Let's add it to commit because it's actually the same. I mean, it is in the scope of erasing an error. Okay, now, okay, so now let's have some opcodes. Now, if opcodes are empty, if opcodes are empty, that means that we couldn't parse in a proper way source code, so and the error is already raised. So now we don't need to do anything and just return an empty opcodes. Because that means that we have malformed source. If we do first some opcodes, let's just append them to the vector. Okay. Yep, and it compiles even without a single warning. Build. Let's clean it. Let's see. Okay, we have warning. In Lexer. Anywho. We could raise an error here. Oh, right, okay, we don't raise error in Lexer. So now, okay, I think we are going to finish here right now because next we would need to implement tests for the parser. So, and that's boring. I'll just implement them during the week, and then in the next weekend, we will see what we are going to do because I don't know at this point. Because if parser is parser works. So the parser is basically the last one, the last puzzle in this puzzle. It's the last part of the puzzle. So after parsing, we have opcodes that we can just write to a binary file, and this binary file is going to be disk of our virtual machine. So virtual machine is going to read this disk and eventually, of course, the opcodes, and then execute them. So it's pretty near to have working virtual machine. So I think if tests are that I'm going to implement will work, in the next weekend we will implement Virtual machine. Okay, that's neat. That's dope. Thanks anyone if anyone watched it. Anywho, bye. See ya.